Hello, everyone. Hi. My name is Kundana, and with me is Guy.
Hello.
We are both program managers in the Azure Compute team. And today we are going to talk about two PaaS options, specifically focused on open source options. One of this is VM scale sets, and the other one is Cloud Foundry. And we'll talk about how these two platforms can help with your PaaS workloads. So I'm sure all of you have seen all the announcements that went out today and yesterday regarding the new PaaS options that are available. So if you look at, on the left side, we have PaaS platforms that run on infrastructure where your applications are running on virtual machines, and you have PaaS capabilities. And then we have applications that are built on these various dev frameworks. So this spectrum is targeted for different kinds of applications. If you have an existing investment, a good place might be to start exploring how VM scale sets or container service might work. Or if you have a new microservice application, then we have services on the right that might work. And similarly, so this is additional categorization of these PaaS services, whether it is lift and shift or targeted towards SaaS or line of business applications. In today's talk, we are not going to cover everything, all of these. Our primary goal of this session is to talk about these two options. So we will talk about what VM scale sets is, how it is a platform for a scalable PaaS applications, and we'll talk about the open source options and how it fits into the spectrum. Okay, so how many of you use cloud services? A majority of you, okay, good. So if you've used cloud services or any other PaaS platforms today in Azure or anywhere else, there are certain expectations from the platform, So you want to use a PaaS layer primarily because you want to manage your services, not servers, By that, you mean you want auto scaling to be part of the platform, you want auto OS update to be part of the platform, app monitoring, application lifecycle management. These are some of the capabilities. Now, in addition, if you want a hybrid strategy, you also want a PaaS platform that does not have vendor lock-in, or that can support customization, or that can support capabilities where you can bring your own operating system. And additionally, depending on the vendor, you might get additional options like hybrid support or high-density options. But these are the most common PaaS capabilities that application developers would like to leverage when they run on any PaaS platform. So in today's talk, we'll talk about, again, these two solutions, how VM scale sets provides these on Azure, and we'll also look at how Cloud Foundry, which is an open source platform, provides this on Azure. So Guy will walk through the VM scale sets at this point.
Thanks, Kundana. So we'll start down in the infrastructure and talk about this thing that we announced was GA today, virtual machine scale sets. This is very exciting for me. I've been working in the team working on VM scale sets for a long time, so it's great to see this make it to GA. On the face of it, virtual machine scale sets are simply a way to manage a collection of virtual machines, to deploy them, manage them as a set. It comes with some nice features, like it's very easy to integrate it with Azure Autoscale. It integrates very well with the Azure Load Balancer. It integrates natively. You don't need to go register with NAT pools, for example. It's just a machine comes up, it registers, machine goes down, it deregisters. You could look at it as an Azure compute resource. So in other words, just like Microsoft.compute/virtual machines, you get Microsoft.compute virtual machine scale sets. So you can treat it as one resource, and that gives us several advantages, which I will go into. So beyond simply being able to manage VMs as a set, what it really does is it makes it easier to create your own platform services. But another thing is it makes it easier for you to engineer cloud scale compute patterns. We like to call it a platform-independent infrastructure for PaaS. In other words, it's down at the infrastructure level. You've got all that control, but it's very easy to then build PaaS-like services on top of VM scale sets. And that's why services like Service Fabric, Azure Container Service, build on VM scale sets now. So when I say cloud scale compute patterns, let's look at that a little bit. I'm guessing that most of you are familiar with the cattle versus pets analogy, where pets, your virtual machines that you give individual names, they have unique characteristics, you take care of them, there's a management overhead that doesn't really scale out to cloud scale. So you have the concept of cattle, where machines then are numbered, they're inherently replaceable, interchangeable, much less overhead managing them at scale. That's the basic analogy, but of course there are nuances to that. A lot of real-world solutions, if you think like container orchestrators, for example, you have a set of agents which you could run as your cattle, and then you have a set of control nodes. There's other concepts like immutability, where you don't want to go do deployment time configuration. You want to have a new image, swap out the old image, swap the new one in. So there's kind of bigger patterns like that. And then, of course, there's auto scale. So you've got work to do. You want your basically your numbered nodes to scale out to do all that work, and then to scale back in to save cost when the work is done. So in terms of analogies, the guy who actually came up with the cattle versus pets, Gavin McCants, he said future application architectures should use cattle, but pets with strong configuration management are viable and still needed. And I think that's a good way to characterize it. So pets, I definitely get that analogy. We love them. They're unique. These are my cats, by the way, because I couldn't be bothered to do a copyright search of images. Cattle, however, because of these nuances, different types of patterns, I like to think of, if I'm going to go with an analogy, I like to think of something that can potentially expand to use up resources, that can auto-scale, and also potentially have control nodes. That's why, in my case, I have a load of fish with a duck on top. There is a duck in that picture somewhere. And with that, I'll guarantee I won't make any more tenuous zoomorphic analogies for the rest of this session. I'll try and leave it at that. The point I'm really making is that these analogies kind of break down, but cloud scale compute patterns, you definitely have a need for those non-individual nodes, and that's really our goal with VM scale sets. So I'll switch to looking at how you build a VM scale set. You could compare it. They're part of Azure Resource Manager, which means we get all the things that you get with Azure Resource Manager. And you can compare building it to how you would build out a virtual machine. You would start with, you'd create a resource group, you'd create a virtual network, you'd create a subnet. If you were building a virtual machine, what you might do next is create NICs, for example. And you'd create some of the underlying resources that the virtual machine uses. And then as you build out your virtual machine, your compute resources, you then have to correlate them together. So that's a key difference with virtual machine scale sets. You define your scale set. You say, I want this many virtual machines. And then you give it characteristics. You can give it network characteristics, storage characteristics. And then if these virtual machines, when they come up, if you want to run extensions to do deployment time configuration, you can give it extension characteristics. But they're all encapsulated in the scale set. So every VM in that scale set is then configured the same, starts up the same. So if I look at the underlying, like the JSON body when I deploy this, here's my resource, virtual machine scale sets. And the most important property, it's got all the other properties like a virtual machine has, but the most important property is called capacity. And that's how many virtual machines I want. The reason it's important is that it's very easy to change that value. And I'll go a little bit deeper into how you change that value and why it's very easy and what's good about being able to change that value up and down very easily. I've noticed, even in preview, the usage has really gone up with virtual machine scale sets. So these are some of the customers that have been using scale sets in preview. There's a lot of others that we're not allowed to show their logos, but the usage has really been increasing. And then if you're using Service Fabric, soon if you'll be using batch, if you're using Azure Container Service, you're using VM scale sets under the hood because they make use of those scaling abilities. So I will switch to just go and deploy a virtual machine scale set. Here's my portal. If you saw Corey do this yesterday in the portal, deploy a VM scale set, the portal team, they work really fast, and they've already added some new features since yesterday. So I'm going to click New. And now if I click on virtual machines, and then I can look at the featured apps, I can scroll down, and there's virtual machine scale set Windows, virtual machine scale set Linux. So it's very easy to discover now. Or I could do a search. I could type scale, and then here it is, virtual machine scale set. So I'm going to go deploy a Linux virtual machine scale set. So there's a basic description, and it's always going to be part of Azure Resource Manager. So there's a set of basic settings. So I'll give it a basic name, GB build. I'll just give it a password. Oops, I typed the password wrong. And then I'll create a new resource group and give that a name too. Give it the same name. And I'll let the location be Southeast Asia. So then comes for the interesting parts. I can pick what type of OS that I want in here. It's already a Linux virtual machine. Let's just click that again. Maybe I'll pick Core OS. And instance count, let's give it 5 instances. And that's it. It's ready to go. So I'll just... one interesting thing that it's doing, which is also new in the portal, it says running final validation. What we're really trying to do is stop having any deployment errors just because maybe you didn't have a core count, or you put in a wrong value. So there's a basic validation done before it goes and deploys now. This is for all deployments that you do from the portal, not just scale sets. So it's ready to go, and I will just create it. Now, one additional thing I'm going to do while I remember is I have a VM scale set running, and I'm going to give it some work to do. And if I get time, I'll come back to that. Now, while this is creating, if I go and look at another one that I created just like that, I think it was this one, I basically use the same menu, and I go see what's there. When you go deploy that, although you just entered some basic properties, behind the scenes, it actually created 5 storage accounts, because it's going to round robin all the virtual machines in those storage accounts. If you create a VM scale set of 100, you'll basically get 20 VMs in each storage account. It's created a public IP address, which is integrated with a load balancer, and plus you have other resources like the VNet, etc. So it's all ready to go. It's got NAT rules defined, so you can go connect to the individual VMs as well. And then if I click on the scale set, it shows what the capacity is, what type of VM it is, etc. So it's basically all ready to go. And as I say, the portal team are actively working on building out new features into these as we speak. So I will switch back to is it this one? 5? Yep. And I'll talk a little bit about how you actually would do how you can do application development with VM scale sets. We can start with Visual Studio. If you use Visual Studio 2013, 2015, you can install the Azure SDK, and then there's really good support for deploying virtual machine scale sets as a template. In fact, I can just quickly show what that looks like. Here's Visual Studio. I can go File, let's see, New, Project, and then click Azure Resource Group, click OK. And there I get a nice choice of templates. So if I want to say a Windows virtual machine scale set, I could just click OK. And it creates a new project for me. And then I can go click on a specific template. And there it is. I can go edit it. And I really like the JSON outline editor in Visual Studio. And actually, one thing I didn't show you, but in the portal, it's also an equivalent JSON outline type editor now. So you can edit directly in the portal when you go and deploy one of these virtual machine scale sets. Actually, it just occurred to me, one other thing I like when I'm doing this, there's a Cloud Explorer as well built in. So as I go deploy these VM scale sets, I can deploy them directly in Visual Studio and then go see the resources in the Cloud Explorer. So I'm just going to flick through these photos as I've just shown you the basic properties. But you can go deploy and then see it in the Cloud Explorer. There's a set of SDKs. Fortunately, because these days when we create new services, we have this schema that's encoded in what's known as a Swagger spec, and then we use the same spec to build out all our SDKs. What that means is that we get all these different SDKs for programming languages that are available now, all supporting VM scale sets. And as of yesterday, the new PowerShell and CLI versions also support scale sets, so there's scale set specific commands in PowerShell or CLI. So this, like I say, this came out yesterday, so if you haven't upgraded your PowerShell, your Azure PowerShell or CLI, you better get upgrading because there's a new one and there's a lot of new features in it. It's also very easy to call REST directly. Quite often, even when I've got PowerShell or there's a Python SDK, I sometimes just like to write little wrappers around the REST calls directly, so I've got that fine-grained control, can write very lightweight program and do exactly what I want it to do. So I'll just show a quick example in Python. Here, this is just a very simple function that does a GET. Nothing to do with Azure. It just does an HTTP GET. And it's a function that then I can then call if I write a REST call for Azure. So here's a REST call. This one, it goes, the way it's built up is, okay, the laser pointer doesn't work very well. It builds up subscription ID, resource groups, the name of your resource group, and then virtual machine scale sets. And with just a simple command like that, I can list my scale sets. So then if I create a function list VM scale sets, it's then very easy for me to write a little loop, perhaps go through all my resource groups, list my VM scale sets. The point is, it means if I want to build out some scripts that go do work, it's trivial. Even using something that you might seem complex like the REST API. And I think, one thing also worth mentioning is that there's, for all Azure Compute and networking resources, there's an API version. You specify it in portals. You specify it if you're calling these APIs. And then the new version is 2016-0330. And that has some great new features, which I will talk about. So I'll switch to a very quick demo of that. Let's go to 7. So here's just a Python program, which it's very simple. Again, it really just does a few queries on VM scale sets. It also imports Pygame. It's just a simple Python program. And what I'll do is I'll just run that. Now, because it's using Pygame, it can give me just a nice graphical view. So here, for example, it's looked at the location. It saw that it's in Southeast Asia for this particular scale set. It's just gone and given me the capacity, the size, what the OS is running, and the capacity is only 1, so it's just listed 1 virtual machine. It's very easy for me to, though, increase that capacity, because it's just a very simple call, which I'll show you, and it starts creating one already. I just hit plus, off it went, just one very small, easy call. Now, I'm not a programmer, but I'm not a dev by any means. I just code for fun sometimes, but the point is it's that easy to just throw this stuff together, and that's what I really like about programming with this technology. So with that, I'll talk a little bit about, we mentioned that VM scale sets, you could think of it as an infrastructure for PaaS. And in other words, it should be very easy to do things like manage scale, to set up things like auto scale. It should be straightforward to handle patching, image updates, application deployment, and lifecycle. So I'll go through some of those points. So as I said, altering the scale is very easy. This is actually the whole REST body when you send it. You give it the VM size and you give it the capacity. That means scaling up or down. You can scale up to 100. You can also scale down to 0 if you just want to define your resources but not have any compute costs. So it's that easy to just add and delete VMs, which is why it integrates very nicely with autoscale. And as I said, these VMs, they're balanced across storage accounts. They're also balanced across fault and update domains. So if a rack catches fire, you're not going to lose your whole VM scale set. You're just going to perhaps lose a small subset of them that happen to be on that rack, but they're evenly balanced. And then because it's just one resource, we can also take advantage of other things. Because one resource call goes down to the fabric, we can optimize that call. So there's a new feature called over-provisioning. If someone asks for 100 virtual machines, behind the scenes we may create 120 and then take the first 100 that come up and delete the other 20. That lets us greatly improve deployment reliability, but also performance as well. So because we've got this structure of virtual machines, it makes it much easier to do things like that and then to optimize. Another thing you can do is, if 100 virtual machines is not enough, now we've got customers running with 1,600 cores. They're using D14s and 100 virtual machines. But if you want more, and a good example of this is Azure Batch. They create a batch pool which can be many thousands of cores. And they use a VM scale set as a scale unit. So they just create something very stable, like one public IP, a load balancer, a scale set, one storage account, one VNet. And then they can build these up like bricks in a wall. So they find that the batch pool just becomes a logical abstraction over a set of VM scale sets. But because these are larger units than single VMs, it makes it much more manageable. So batch, the next version of batch is going to be building out using scale sets like this. And it's a very efficient way to do it. Of course, you can combine them in different ways as well. You could have multiple scale sets in one VNet and anything in between. So this is just one example is Azure Batch. And we have some other examples in GitHub of like multi-VM scale set templates as well. So let's talk about autoscale. With autoscale, it's just, again, can be part of your template when you're deploying a VM scale set. You define your max and the minimum number of virtual machines, and then you define trigger actions. I don't know how well you can see this, but basically, I've defined a metric trigger, and then a time grain of 1 minute to take measurements, and then a time window of 5 minutes. So after 5 minutes, if the trigger has gone off, say the average CPU across the VMs in the scale set is more than 60%, then it will do, in this case, a scale action, it will increase by 1. Of course, it could increase by 20 or whatever you needed. And you can bundle up these rules. You can have rules to scale down or multiple different rules to scale up. The other nice thing is the way you do notifications as well, because there are standard like audit notifications for your audit log when there's a scale action or email notification. But you can also define webhooks and then custom notifications and actions such as runbooks. That way, if you decide, for example, I don't want to do horizontal scaling, I want to do vertical scaling, I want to increase the size of my virtual machines, it's very easy to write a runbook to do something like that. Another nice thing is with these webhooks, it's a standard. So there's companies like PagerDuty, for example. They now support webhooks like this. So they work very closely with Azure Autoscale. So now if I do an autoscale action, it can make my phone buzz, or it can send me an email, send me a message through Slack. Pretty much a very large array of configurable actions that it can then take whenever there's a scale action. Next, I'll move on to how you manage updates. And if you're going to think about that, you could probably divide it into 3 basic layers. So you've got your scale set, you've got your large cloud scale application, and you want to update the application. You could do that all at an application level. So for example, your virtual machines are just hosts they're running, and your application, you could use something like Chef, Puppet, a container orchestrator, just have your application running in a container and just not mess with the VMs except for urgent security patches. So you could do applications completely at that level, and you can then not really worry about the underlying infrastructure. If you do need to do those security patches and things like that, though, you could do in-guest updates. So, for example, we have a patch extension, so you could kind of set up a patch policy for all the virtual machines in your scale set. Another thing, though, you may want to do is perhaps your application is baked into your VM image. There can be some good reasons for doing that. Again, it's like the immutable deployment model. Perhaps you have your application there, that's how you want to manage it. We support ways to roll out an updated image to all the virtual machines in a scale set. So you don't have to just like have any downtime when you're rolling it out. So the way you would do that, you could just update the image in the virtual machine scale set properties. You could look at the upgrade policy setting, make sure it's set to manual, which means nothing happens when you change that image. And then there's an API call, manual upgrade, which you can then call against specific nodes. And that way you could manually roll out an update. For example, you update domain by update domain if you wanted. Also, if there was a node which wasn't running very well and you wanted to effectively reset it to factory settings back to the original source image, there's another API called reset nodes, and I've included there an example of calling that in PowerShell. In the future, we'll be looking more into the whole concept of updates, because certainly PaaS users take things like automated rolling updates, for example, for granted. So we'll be looking at more of ways to automate that, but for now, you can do it manually. I'll look a little bit at application deployment. So if, for example, again, there's multiple ways you can do application deployment as well, and it kind of mirrors the updates in a way. Baking in custom images, having your immutable deployment cycle, that makes a lot of sense, but then do you really want to maintain this image all the time and go to all that extra work? You could use VM extensions. So here's an example of, say, custom script for Linux, and the Linux diagnostic extension, so I can emit performance data for autoscale. So you could do runtime. When each virtual machine deploys, it can go install whatever it needs to, and you can do it that way. And then, of course, there's the higher level cluster manager. So your application deployment can be done this way as well. So there's quite a lot of choices in that sense. And the next thing I'll talk about is going from just kind of this level to, if you're going to work with, say, the baked-in image model, the immutable model, you need a lot of support. You need some kind of deployment pipeline to do this safely. So I'll talk about another open source project, which is Azure Spinnaker. Many people here heard of Spinnaker? Quite a few people. It's what Netflix use. I'm just distracted because my phone is ringing because I've configured that PagerDuty when I scale up, and because of that work that I triggered, there's like 3 virtual machines coming up there now. So that was right at the beginning when I started one of the virtual machines working. But so getting back to, I want to go deploy an application. There's a nice pipeline you can do with Spinnaker. So Spinnaker is what Netflix use, and they've been using it for years, built up a huge amount of expertise. It was originally working on AWS, but there's been this project to create a driver for Azure. So now you can use basically the same methodologies that Netflix have built up. And Netflix have been very helpful in terms of putting this together and working with us, where you can do something like a dev can check in some code that can automatically trigger a build, which can be done through a Jenkins pipeline, which does all the work needed to test and build and bake an image. And then that can trigger the Spinnaker pipeline, which can then orchestrate across all the testing and like building a test virtual machine scale set, and then using the application gateway to swap out the production, swap in the test gateway. So it's a really nice working pipeline. So basically, your VHD, you then set up in Spinnaker the testing, staging, and production workflow. I'll just briefly show you what that looks like. So here, for example, this is just one of the, I could go and edit one of the files that I use for one of my images. I'm not going to go and edit it now, but let's suppose I edited it, I checked it in, then it would trigger this Jenkins pipeline. So basically, the Jenkins pipeline, it starts from the bottom, it verifies the image, you can set it to run unit tests, smoke tests, integration tests, create a fully baked image. Then it will trigger the Spinnaker pipeline. So the Spinnaker pipeline, basically it starts with the baked-in image. Then you can define, say, a set of tests, integration tests, unit tests to run in parallel. It can deploy a test VM scale set. Maybe you'll add a manual stage, a go, no-go stage, once that's created. And then you can go do a deployment and deploy your VM scale set. And there you have options like to deploy into a specific cluster. You can go. You can say what capacity, and because you're using VM scale sets, you're not limited to just doing this VM by VM. It can support your cloud scale architectures just naturally. And for example, I can go look at the clusters. I can go look at the status of my test clusters, my production clusters. So it's a very nice model, and it's great to see this working in Azure. And there's more work that they're going to be doing. It's an ongoing project, and if I just a quick look at the roadmap, what they're doing next, they're working on zero downtime deployments. So looking at ways that your production just stays running. There's no few second blip while the application gateway swaps. They're going for blue-green type configuration, as it's called. Also easy rollbacks and just one click to get started. So AZ Spinnaker at Microsoft.com is that project if you're interested in that. And here's an example of a heat map from you deployed a big cluster. That's kind of another part of the project is just generating nice reporting and heat maps of your virtual machines. So that's all we'll do down at the low-level infrastructure. Next, Kundan is going to look at a higher level, implementing an open source PaaS platform on Azure. And again, all of those PaaS features that you take for granted, how they integrate with some of the higher level PaaS services. So over to you.
Thank you. Thank you, Guy. So that was very exciting, VM scale sets overview. One of the things I wanted to mention is I also work on cloud services, and some of you mentioned you use cloud service. So we've been working very closely with Guy to identify the features which our customers loved about cloud services and making sure that we build those. And also some of the gaps where cloud services did not address those scenarios and providing this. So for example, things like using custom images to fast provisioning, Linux support, right? These are all super exciting features that VM scale sets provides. And coming back to the topic of open source support, open source PaaS, right? So when a VM scale sets, clearly you can run it on Linux virtual machines, you can put any workload of your choice. So today, in the next 20 minutes, I want to talk about yet another open source solution that works great on Azure today, and this is Cloud Foundry. How many in the room are familiar with Cloud Foundry or have used Cloud Foundry? A few folks, okay. So let me introduce you what Cloud Foundry is and what we have been doing to support Cloud Foundry. So this is the second half. The agenda is the introduction. How do you deploy? After you've deployed Cloud Foundry, you're running on Cloud Foundry. How can you use other Azure services? So this talk is not about getting into depths of how Cloud Foundry works, but this is about how Cloud Foundry is integrated with Azure. At a high level, Cloud Foundry is an open source PaaS platform that supports multiple languages. So it can be run either on public cloud or on private cloud. And finally, the very interesting part is it is IaaS agnostic, so it can run on any IaaS infrastructure. So the next question is, so we have Cloud Foundry that works great. So why do we want to bring it on Azure? Why do we want to, we have seen a few PaaS options. Why do we want to support Cloud Foundry as another PaaS option, first-class PaaS option for our customers? So the reason is Cloud Foundry brings great support for Java workloads. And it, because of its cloud agnostic properties, it actually works very well for customers who want to have a multi-cloud strategy. And Azure provides a set of rich capabilities, and there is a great opportunity for us to integrate Cloud Foundry with these rich services. And finally, in our first slide, we talked about like the PaaS capabilities that everyone likes, right? So with Cloud Foundry, we also have an opportunity to provide an on-prem implementation with Azure Stack. This is also a work in progress. So these are some of the reasons why we are investing in Cloud Foundry and Azure. So where we are today on Cloud Foundry. Cloud Foundry is an open source project that we have contributed to. It's an open source PaaS platform that is generally available on Azure today. There is a commercial version of Cloud Foundry, it's called Pivotal Cloud Foundry. Pivotal is the company behind Cloud Foundry, and that's also available in Azure today as a marketplace solution template, which was announced in the keynote this morning. So we started this project roughly a year ago. And it's been a very interesting and exciting journey. Around May 2015 last year, we announced the preview of Cloud Foundry. That's me doing a homemade video to announce this. And fast forward 10 months, we are at Build today. We are talking about this. We have fully integrated. We have GA'd the open source Cloud Foundry. Pivotal Cloud Foundry is available on Azure today. And we've built there's a huge momentum, especially with all the customers who are interested in this on Azure. So while we've GA'd this service, it's very important to go back and look at our goals, right? Again, I said, why are we doing this? What are our goals? So the first goal we have for Cloud Foundry is to ship an all open source project, and that's what we've done. That is our GitHub URL. The support for Cloud Foundry is available as an open source project. And the second goal is provide a consistent experience with other clouds. So that's the value proposition of Cloud Foundry, right? No matter what IaaS infrastructure you are on, you have a consistent experience. And the third goal is to, as part of shipping an open source, align with the community engineering practices. Then the other goal we have is, as we bring this open source workload in Azure, we want to provide a rich, deep first-party integration with Azure. So in addition to using Cloud Foundry provided tools for deployments, we have also provided Azure templates, which I'll show you in a bit, to simplify and automate the deployment experience. I already mentioned Azure Stack. And in addition, we are also working on integrating this with Azure first-party services like SQL Azure, Event Hub, Service Bus, et cetera, to integrate this and provide a rich experience. And finally, we have an ongoing committed roadmap to this open source project. The source code is fully supported by Microsoft, and we go through the standard engineering processes of the community when we add new features and capabilities. So let's talk about what does Cloud Foundry support on Azure mean. What did we, what did we implement, right? What's going on behind the scenes? So if this is our Azure infrastructure, which is virtual machines. This is the infrastructure service, IaaS virtual machines that run on Azure data centers. So what we have done is to deploy, Cloud Foundry is deployed by a tool called BOSH. BOSH is equivalently, it's a CF bootstrapper. So what we have done as our open source project is to implement an Azure interface. It's called a CPI, Cloud Provided Interface. So every cloud has its own CPI, and we have implemented the Azure CPI. In addition, we have also integrated with Azure templates. So this BOSH CPI can now deploy Cloud Foundry on Azure virtual machines. And once Cloud Foundry itself is deployed, the infrastructure, the PaaS platform is deployed, developers can use their tools of their favorite choice to push applications onto Cloud Foundry. Right? So this is the end-to-end picture of how this whole thing comes together. All right. So a little bit about next is Pivotal Cloud Foundry. That was the underlying work that we have done for open source Cloud Foundry. And with Pivotal Cloud Foundry, we have taken the same open source pieces that we have shipped, and it's now delivered as part of Pivotal Cloud Foundry on Azure. And Pivotal is the company behind Cloud Foundry. So if you've, a couple of months ago, I had an experience of a few folks from Pivotal. We worked together on a hackfest to identify how we can simplify this experience. And I've gone through the steps manually, and now I really appreciate how much this template simplifies the entire experience. So this single-click template, which I'll show in Azure Marketplace, you give it a few parameters, and it sets up roughly 53 virtual machines. It installs the Cloud Foundry PaaS layer, the elastic runtime. It also installs some of the services out of the box, MySQL, Redis, RabbitMQ, along with Spring Cloud services. All of this at a click of a button. Let me quickly show you how this looks like. So this is the Azure portal. In Azure portal, searching for Pivotal Cloud Foundry shows this. So create an instance. A few parameters it takes. So this is basically, it's setting up those 55 virtual machines. It takes as input a storage prefix. And what it creates is a jump box. The first thing it creates is a jump box in cloud, in Azure, and that jump box is what you would use to manage other machines. So this is the SSH key for the jump box, and this tenant ID, client secret. This is a service principal that you are creating for your subscription, because all these 55 virtual machines are provisioned by Bosch on behalf of you. And you do not want to put your subscription information there. So you would create a service principal and give the minimum required permissions that are required to create these virtual machines. And then pretty much basically specify a resource group, location, and OK. I will not kick off an install here. This takes a few hours, but it does the standard template validation that Guy showed. It ensures that you have sufficient number of cores, etc., and then deploys these many virtual machines and brings up the infrastructure. So when it's done setting up, this is the portal. This is the Pivotal Cloud Foundry application manager console that you would use to deploy and manage your applications. So this instance is running in my subscription on Azure. All right, so going back to slides. So a little bit about, so if you look at how Pivotal Cloud Foundry is layered on top of Azure, so all the blue layers are the services that Azure provides. On top of it, PCF provides an application framework for Java and other languages. All right, so we deployed Cloud Foundry in Azure, right? We've really simplified that deployment. So then what, right? What else do we want to do to take it to the next level? So here's where concept, so basically think of a scenario, right? So you have deployed an application, and just take an example. In this example, your application wants to write to a storage account, as a storage as a service. And as a developer, you do not want to provision the storage accounts or manage the storage accounts. You want that service to be available to you, and you want your application to use that service. So this service in the language of Cloud Foundry is an external application dependency. This service could be data services like cache or any of the database services, or a monitoring service. This is an external service that your application is consuming that you want to use. So roughly this looks like this. So the way this is delivered in Cloud Foundry is using the concept of service broker. So service broker is basically a thin interface that sits between your application and the service. It is a translation layer. When your application is talking to the service, the service broker is the one that is performing actions. As an example, your application will say create a service. It doesn't know how to create a storage service. The service broker knows how to create a storage service. Right? So similarly, there are service brokers that come out of the box. Then all the service brokers have a consistent interface. So Cloud Foundry has a marketplace. If I go do CF Marketplace, CF is the Cloud Foundry command line tool. And if I do CF Marketplace, it tells me what are all the services that are available on my installation. As an admin, I can choose to add as many services as required or remove. And once, as a developer, if I want to use a particular solution or service, there are a few commands, very simple, straightforward commands called create service, bind service, and redeploy my service. At this point, your application is now talking to this service. So let's look at an example of how this service broker, we are using it in Azure to connect these services to these applications to Azure services. So as an example, we talked about a storage broker. A basic functionality of storage broker is behind the scenes, it provisions the storage accounts, and it binds your service to the application. So, and it does it using the concept of environment variables. So all the account information, the container information, the storage key that are passed from the service to the application using environment variables. And I'll show that to you in a bit. So let's actually see how this works. Okay, so in my application portal, let me orient you with this application manager portal before we do the demo. So it has the concepts of orgs and spaces. I have created a test org here. In the test org, I have a space, and here are where my applications are deployed. I have a few applications that I've deployed here. One of these is a Java application that I have pushed. And again, pushing applications into Cloud Foundry is really straightforward. There is a command line called CF push that you would do. I will not push it, but I just want to show you. When I do CF push, it goes and pushes this application. Now this application, if I browse to, it is a heat map. It shows for this retailer, information about in each state. So this application, it's a Java application running on my instance. Now, basically, it says there are no services bound to this application. So this application this application at this point is designed to can use a service broker. So what I would do is here go to services in the portal, and let me see what services have already been provisioned for me. I can use two services. One is the blob service, and this is the RabbitMQ service. And I say bind. So I'm now binding this service to my application. Once I do bind, what it does is it populates these environment variables. There you go. So this environment variables is how the service information is communicated to the application. Now that we have bound this service to the application, let's go back to our demo. I need to restage. I don't remember if I did it, but let me restart the application again. All right, and hit refresh. Oops, it's still restaging. One more time. The network has been very flaky today. Hit too soon. Okay, I think I'm hitting some network issues. I'm going to try for the last time. Okay. No luck. Oh, there you go. So this was the map that we saw earlier, and now you can see data is being streamed here, right? So I'm starting the data stream. There, it's populating the data. So if you can see, I did not go change my application. My application is still the same. I am dynamically binding it to a service. So this service broker, again, can be really extended to Azure first-party services. We have a work in progress at this point. We have a prototype of a storage service broker that I want to show. So in my space, I have an application called Storage Consumer. So what I've done is there is a storage broker that I've already published to my marketplace. This storage broker is a very straightforward implementation. It uses the Ruby SDK, and what it does is provisions, creates a storage account, creates a storage container, and keeps it ready for my application. So I have already deployed this application, and in services, I already performed the binding. So if I look at the environment variables, see this service now, this storage blob service broker, via the environment variables is giving me this information of storage account, container, key, etc. that my application can use to communicate with storage. So since I've already deployed, I just want to hit this endpoint, one of these. So this is the application. If I hit refresh, it might fail. So I just want to show. So basically, at this point, my application, yeah, network is actually super slow. Let me try one more time. At this point, my application, I want to try downloading a file, if it works. OK. So apologies for the network glitches. But the idea is, OK. So but the idea is we can take this service broker concept and extend it to many other Azure services. Oops, what happened?
Interesting.
OK. All right. So we have two branches. One is our, this is the first branch is our CPI branch. This is the Azure plugin that we've implemented. This is an open source project, as I mentioned. You can contribute if anybody's interested. The second branch, the branch information I don't have at this moment. It's in the final legal review. We want to publish it as soon as possible. But if anybody is interested in writing service brokers, these are again very straightforward APIs to provision service, bind service, 4 or 5 interfaces that need to be implemented. This branch information would be available soon. And we've, in the last few months, I connected with multiple customers who've expressed interest in using Cloud Foundry and Azure. And when I talk to them, right, like in a lot of discussions, a lot of, just to give an idea of the possibilities, what are the services that we are looking at it. This is not a committed roadmap, but this is just something I've thrown together based on the feedback that I've seen. But, these are like the blob storage. Some of the pieces are work in progress, but these are all the services that can be integrated with Cloud Foundry. So your application still is using an open source platform, but it still is able to connect with all these Azure services. All right. So almost coming to the end. So Pivotal Cloud, open source Cloud Foundry has been GA'd, and we have been working with Pivotal to make the service available. What's the roadmap? So basically, in November is where we announced the preview of Pivotal Cloud Foundry in Azure. At Build, today we announced the last but one milestone. This is the internal code name is Gamma, but this is a marketplace template. And finally, our next goal is to make this fully available by summer timeframe. All right, so then the next question that I get often from customers is, how is all of this supported in Azure? What's the support model? As I mentioned, Cloud Foundry is fully supported. Open source Cloud Foundry is fully supported by Microsoft through standard support channels. And with Pivotal, we have a joint support model for supporting Pivotal Cloud Foundry and Azure. That sums up Pivotal Cloud Foundry on Azure. Is this your slide?
Yeah, well, ours. This is really just some links that you may find useful for virtual machine scale sets and some of the documents.
Yeah.
Also, webhooks. I went through it pretty quickly, but webhooks is very powerful. And things like Azure Alerts and PagerDuty integration, there's just some links for reference there. Also, most welcome to come and chat to us and ask questions or get our contact details. There's also, I'm not sure if that was the right link for Cloud Foundry, but we added that there as well.
Yeah, that's actually the right link.
OK.
All right.
And there's a couple of slides people asked us to advertise their lab hours and things that you can.
OK. And then there's one more.
Yep, there's the Azure Clinic.
OK.
It's open one more day.
All right.
And then one more.
And finally, please submit evaluations for this session. That sums up the talk. We are here if you have any questions.
All right, thank you.
Thank you. Thank you for
Thanks.
coming.